we're going to use our new cool first and second derivative tests to sketch this graph. And obviously, you learned back in college algebra how to draw this graph. There was a lot of steps. This actually should make it somewhat easier. Some things are still around, but a lot of this will make it an easier process. So, hey, something you can go back and tell your algebra self that, hey, it does get better. So the first thing you're going to want to do on any of these is you're going to want to take the first and second derivative. So I'm going to start right there. My first derivative here is going to be 12x to the third minus 12x. And then my second derivative here is going to be 36x squared minus 12. So I've just taken the derivative twice. Then once I've taken the derivatives, I need to find my critical points and my inflection points, right? So I'm going to set each of these equal to 0, and I'm going to solve. And looking at this, you should immediately see a factoring problem. And again, you're going to apologize to yourself back in college algebra when you said, I will never use this. Right here, we're using it, okay? So we're going to factor this, and we're going to get 3 inflection points. Then I'm going to do the same thing over here, and I'm going to get 36x squared, and I'm going to skip a step here and just rewrite it. It's equals 0. I move the 12 over. X squared equals 12 divided by 36. X squared equals the square root of 1236, which is plus or minus, let's see here, this is 4 square roots of 3 over 6. No, 2, because I took the square root of that. So it is the square root of 3 over 3, which is approximately 0.6. It's like 0.578. And the reason I know that without putting it into my calculator is because this is trig. You should recognize that square root of 3 over 3. So I know the decimal version of it. Okay, now what we're going to do here is we've got this information. I am going to, now at this point you can do two things. You can stop and find all the graphing points that you're going to need to graph with, or you can draw your chart, kind of whichever one you want. Kind of goes either way. I think I'm going to find my graphing points so I have them and I'm done with them, okay? Now, when we do our graphing points, we are going to go back to the original equation. So when you find graphing points, you go to your original equation, and this is probably the easiest mistake to make is you're going to go, okay, I need to find what each of these graphing points are. You're going to try to put in your first derivative, but no, I want to put it in my original equation. So I need to find f of 0. I'm trying to get my thing. I need to find f of -1 and f of 1, okay? And the same thing over here, I'm going to find f of the square root of 3 over 3 and f of negative the square root of 3 over 3. Okay, and I'm going to find all these, so that way I have graphing points for when I go to start graphing. So when I put in 0, that gives me 0. That's pretty easy to see. This is going to be 3 minus 6 plus 3, which is 0. Um, because, and then I know the other one, because this is symmetric. So this is an even function. That means it's symmetric, which means that this is also 0. So then my graphing points are 0, 3, -1, 0, and 1, 0. So these are my x and y intercepts. So I don't actually need to go back and find them later, but if you didn't get your x and y intercepts, and that's just kind of random luck that I got these there when I picked this one, is that you would want to also, when you go to graph, find those x and y intercepts. And we'll double check and make sure we have all those when we get there. Then I'm going to do the same thing here. This one, though, I'm probably going to put into my, this a little bit messier. I probably would want to put this into my calculator. So let's do that. So let's get out the calculator here. Okay. And so I'm going to do the square root of 3. I need to get out from under that, divided by 3. Okay. And then I'm going to take that to the 4th power. And then times it by 3. And then I'm going to minus, okay, so let's see here. 6 times, and then the square root of 3 divided by 3 squared, okay, plus 3. Okay, so 1.3. So this is 1.3. And then because this is symmetric, I don't have to do the other one. If you don't trust me, obviously go back and do it. But how we know it's even, remember, both of these are even numbers. That means it's an even function. That means it's got symmetric about the y-axis, and both sides are going to mirror each other. So that's always a helpful little thing to sometimes notice. You can kind of save yourself some work on that. Now we're going to go back at this point. So now we have our graphing points, which we'll need later. But for right now we need to make our cool chart that's going to tell us when we're increasing and decreasing. So I'm going to put all my points in. I'm going to put in -1. I'm going to put in, I said this was -0.6, 0, and then 0.6, and 1. Okay. So now I'm going to test these. Now, when we test this first derivative, we test this in the first derivative. So this is again where we get confusing. We were just using the original function to find the graphing point, but now I'm going to go back and I'm going to use this first derivative. So I'm going to use 12x cubed minus 12x. So 12x cubed minus 12x, and this over here was 36x squared minus 12. I'm just kind of making it easier for myself to see on the page. Obviously, this you wouldn't have this same problem if you were working this on paper. So I'm going to pick a point out here. So I'm going to pick out -2. And when I pick out -2, I'm going to get a -8. So I'm going to get a huge number here. So this is going to be negative. Okay. Then I'm going to pick a point here. Now, here's the thing. I could actually use 0.6 because this is an inflection point, right? But I'm going to pick one on each of these. I'm using these as checkpoints to make sure it's working. So I'm going to find a handheld calculator to make this easier to do here between screens. But I'm going to put in -0.8. So I have 0.8 times 0.8 times 0.8. Times 12, which is like 6 point something. So I have a -6.2, okay? And then I have 12 times 0.8. This is going to become plus 9.6. So now I'm at a plus, which makes sense because this was, remember, this was a critical point, so I should see a change. Now, if I put in this point, -0.5, I should still get a positive number because this is not an inflection point, but it's a good way to check, make sure everything's working. So if I do 0.5 times 0.5 times 0.5 times 12, I get like -1.5. And then 12 times 0.5 is 6. So positive, which is what I wanted. Now I'm going to come over here, and this should be a change in inflection point. When I put in now 0.5, so 0.5 times 0.5 times 0.5 times 12. So I get my 1.5, but now I'm positive. But now when I subtract it, this is going to be -6. So now I'm a negative, which I would expect. Now I'm going to put in my my positive 0.8, and I should get another negative. And again, this is a good way to check as you go through. Last one, this 2 here, I expect a change in concavity. Not in concavity, in increasing and decreasing. So I expect this to go positive. So now I'm going to put in this. I put in 2. I'm going to get 8 times 12, which is 96. And then I'm only going to subtract 24. So now I'm positive. So you can see I'm decreasing all the way to here, then I'm increasing, then I'm decreasing again and increasing. Now I'm going to check my concavity. So I don't like that color. Okay, so now I'm going to come down here. I'm going to put in -2. Well, that's going to become a positive, right? So this is, I'm going to get 36 times 4 minus 12. So you can see here, I'm only taking away 12. This is going to be concave up. Now, I don't expect here between 0.8, if I put in 0.8 here, I don't expect a change, right? Because it is still, I've got an inflection point. But just to check one of these on one of these sides. So if I do, see 0.8 times 0.8, which is going to be positive, right? Because it's going to do that. Times 36, I get 23.04 minus 12, which is still concave up. But now when I put in, I should get a change here. So I do 0.5 times 0.5 times 36. So this is 9 minus 12. Oh, now I'm concave down. Okay. Now here on this side, this was not, so then I'm still concave down. But this is my other inflection point. So when I check out here and I do 0.5, I should go back concave up. So I'm going to do that. I'm going to do 0.8 times 0.8 times 36, which is 23. And see there, I'm back. So now I'm concave up. Okay, now we're going to take all this information and we're going to put it on our graph. And this is where those graphing points come in useful. So I'm going to come and I'm going to start graphing those first. So I have 0, 3. So 1, 2, 3. And I was at -1 and +1. Okay. And so this is also where you'd want to be checking and going, do I have any more things? And then let's see, what did I have? I have -0.6. And where was I at? 1.3. So 1. So there's my inflection points. Okay. That though gives me some idea of where I'm doing. So as I come out here, the other thing, if you remember from our leading coefficient test, I know that both my ends are going to be going up. College algebra. So as I come in, I am decreasing. Okay. Decreasing in. Okay. And then I'm going to start increasing. And then I'm decreasing and I'm increasing again. If you remember Descartes' rule, that would also tell you bounced here. I can see here, right here, there's my concave up, there's my concave up, and here's my concave down. That matches mine. And usually what you can't see, because you can't see me here, is I've usually got pictures as I'm going, okay, I'm concave up, what's happening here? Concave up, okay, now I'm decreasing. You're kind of fitting it to what you're doing, but as soon as you have those points, I can see right here, that's my change in concavity as I go from one to the other, and it makes sense as I start drawing it. If you're stuck, throw graphing points at it. There's no such thing as too many graphing points. You can always throw a couple extra graphing points and go, I'm not sure what's going on in this chunk. For instance, you're like, I really want to verify. Pick a point out here. Pick like -10 and make sure it's up somewhere up high. You can always throw extra points, just like when you were learning to graph. You can always use those tricks from college algebra to help you go, okay, I'm not sure what's going on here. And those things, those leading coefficient tests, which were really easy to do, those are things that you can look at, things like symmetry. I knew both sides had to look the same because of that symmetry, because it was an even function, which told me I had symmetry down my y-axis. Things like that, if you can notice them, will help this even though we're learning our new methods. Okay, so our goal is take all those pieces, put it together, and hopefully it's going to become to a nice, pretty graph.